So thanks for coming. We're talking about fortifying the future and how to secure AI in such a dynamic landscape that we have today. My name is Heidi Bronson. I'm a partner security solutions software engineer for SUSE.
And I'm Alex Festa. I'm the product manager for SUSE AI. I'm working with Heidi on this amazing stuff.
So if you guys have questions, you're welcome to ask anytime, or you can wait till the end, whatever works. So the reason why this is such an important subject is because AI is really driving our discussions, our decisions, it's automating our processes, and it's really going to shape how our future is moving forward. And I think it's important that we do it right in the first place. So we're going to kind of talk about the AI evolution in the future, the challenges and concerns that comes with implementing AI, how do we balance the opportunity and risk, and how do we secure by design? So first, let's dive into the AI evolution and future. So AI, we all know, is not new. I mean, it's been around for a while, but there has been things that have really drove what we have today. So this is called the Gartner hype cycles. They do it for new technologies. Even though this is 2024, I thought it was still really relevant today. So we have the innovation triggers, which are typically things that come out that everyone's super excited about. ChatGPT is one of them. And everyone kind of starts pouring in their money, and they're so excited, and they're just, all their time and effort kind of goes into it. So when that happens, we end up...
Come over.
Hi. We end up going into the peak of inflated expectations. So everyone thinks that it's going to be like the new greatest thing, it's going to solve all the problems, but reality is never really the same as what we hope it will be. So we end up starting to dive down into the trough of disillusionment. And this is kind of where we are right now, because we're starting to realize some of the security risks, the challenges that we're facing with it, and it's not really going to solve everything. We have to be able to limit the use cases that we use it for and really be able to concentrate on where we need it in order to move forward. And then this is really necessary, though, because then we end up going into the slope of enlightenment, where we actually start solving the challenges. We start actually implementing it where we need to implement it. And then thankfully that takes us eventually into the plateau of productivity, where it's something that we use every single day, and it's really part of our businesses, and it's reliable. So, but this is a very important reminder that implementing AI is a journey, it's not just a destination.
Yeah, and if I can make just really quickly, this is pretty interesting that if you look at the slide, you immediately see TRISM. How many of you knows what TRISM means? Damn, I have gadgets for you. Now, TRISM is basically trust, risk, and security management. And that's pretty interesting how Gartner pitched the fact that exactly like prompt engineer, responsible AI, or even, let's say, AI, composite AI, and et cetera, are coming in. Also, the concern about security and how you secure and design a security system comes to be more important. So really give you this idea that the landscape is maturing really pretty quickly. So we are still experimenting, we're still trying to do stuff, but at the same time we start to get concerned around security and basically understanding that, okay, we need to have some policies in place, we need to have some rules in place, because otherwise it will be just a mess, and et cetera.
Exactly. And the thing is when people are going through the innovation trigger cycle, they are so excited about it, the last thing they really think about is security, because they want to see what it can do. They're not worried about exactly what the security risks are. And as soon as we have those, we can start testing. But yeah, it's definitely a cycle for all the new technology that we go through. So let's talk about all the different use cases, because AI is not just the Gen AI, right? It's used for lots of different things. We have communication, which is a natural language processing, and that one we're very, very familiar with. We have the chatbots, with translation from one language to another, and it makes life a lot easier. Gemini AI is everywhere. We're seeing it everywhere. Then we have vision. It's not just about seeing something, it's about understanding it. So that's like with manufacturing, we need to be able to do quality control. And it's a lot easier for us to have trained computers to do it than to have a whole line full of people having to do it ourselves. So we're hoping that saves us a lot of time and money on that one. And then recommendation systems are important because people want personalization. You're more likely to have partners and customers that want to work with you if they feel like you understand them and that you're truly concerned about their wants and needs. And so those are going to be very important for us. And then, of course, predictive analytics, because AI is not just about now, it's about the future. And we need to be able to predict the future. If we can predict what's going to be successful in our companies, what our customers are going to want, it's really going to help with our financial forecasts. And then autonomous systems, of course, self-driving cars, robots, drones. This one I'm really looking forward to because I want a robot that, takes care of my house.
Yep.
That'd be great. But unfortunately, like I mentioned earlier, it always comes with challenges and concerns. So these are just a few of them. So we have a rapidly changing tools constantly. It's almost like trying to build a house on sand. Because once you get something built, then the new technology comes, and then you're gonna have, there's always something new and greater. And just within a few months, sometimes things are considered old.
Yep.
And that's frustrating. But one important thing is building a firm foundation underneath it. If we have a firm foundation, then we can be flexible on the top layers. Lack of transparency, because especially with large language models, it's kind of a black box method. It's really hard to be able to see what's making those decisions and what's driving those. And that can come into compliance issues, that can come into some critical infrastructure things like healthcare, that if they don't understand what's driving those decisions, how do we really trust it? And then lack of skilled talent, because AI is not simple, it's very complicated. So how do we have the talent and the time and resources to be able to build it effectively? And then regulatory compliance, which is also hard. It's kind of like a maze because it varies depending on your location, your industry, and then also what customers are you serving. If you want to expand into Europe, for example, or any other place, what are their regulations? And that's very hard to understand sometimes. And then complex infrastructure. Because we're not just talking about AI, we're building on top of other systems. We all have our legacy systems, we all have all these different areas that it connects into. So we have to understand our current infrastructure, and then we have to understand what we need for our AI infrastructure. And then security threats, this is nothing new, but we have new attack vectors, new attack surfaces that we have to worry about and try to understand. And I'll go into that more a little bit later. And then implementation costs, it requires a lot of resources, a lot of data, a lot of power, and we need to be able to balance the costs and the benefits that we get from it.
Yeah, absolutely. No, you're absolutely right. And I was thinking that actually it is pretty interesting because if you look at the use case before, those use cases seems new, but actually take, for example, autonomous cars. So the first autonomous cars was basically developed in Berkeley in 1987, if I remember right. So actually it's not really new. It's pretty old if you look at that. But anybody ever concerned about that? Because it was more, oh, let's try that. Let's try to experiment. Let's try building. And so let's forget security. And we apply the same rule basically everywhere. If you think at any technology we're using today, we basically started saying, okay, first of all, my first concern is that, oh, I don't have talent around that. Like when we started Kubernetes back in time, everybody was concerned that, oh, we don't have Kubernetes expert. We need to learn this. And we forgot about that. Yeah, but we are moving all the workloads. We are moving everything into that. We need to be sure that actually that stuff actually works properly. And the same goes with transparency. You make a great point that it's like, LLM is like, your parents, when you grow up with your parents. There's a moment in your life where you have full trust in your parents. I mean, you have full trust in your parents probably for the entire life. But technically speaking, you don't stop by asking, why actually my parents telling me to do this? You simply trust them because, well, they should not put on harm on you. But basically it's the same. You trust an LLM because you're human, because it basically replied to you in a human readable way, and you trust it. And you don't stop by thinking, okay, this is basically just a mathematical system. What is going under the hood? How it's been trained? What type of data is being trained upon? because maybe it's not that precise. Maybe it's as in hallucination or stuff like that. And around implementation cost, security rest is pretty interesting. Nowadays, we start to talk about agentic workflows, for example. But the more information we plug to a system, the more we expand the surface attack, because we cannot control anymore. We will see later that some of the potential attacks that you can implement against an LLM, and technically speaking, those can be actually hit the entire infrastructure, that is a complex infrastructure. And an implementation cost, because it's a natural consequence. On one side, because you want to have more powerful system to run this stuff. On the other side is that this stuff potentially can raise your cost because it basically is impact your infrastructure in a wrong way or in an unexpected way, and you will go to pay more. So all those things, exactly like you said, it's like building a house. If you don't put the right building blocks at the right place, the house will basically collapse at some point.
So first I want to kind of dig into the regulatory compliance. You can only do a broad overview because this can get very complicated. But we have the EU AI Act, and this is something that is important for everyone to know because our economy is so broad that we need to understand what the other countries are doing. And also, our governments are watching other countries to find out what's working, and they will probably eventually implement a lot of things more broadly as well. So this one's kind of interesting because they kind of separate it out into different levels. So we have the minimal risk, which is like video games, spam filters, things that's not really going to affect people if there's a security risk. Then we have the chatbots, the emotion recognition systems are more limited, but that still starts getting into how people interact. And they want to very much define how that works so that nobody's put at risk from that. There was an issue with ChatGPT with some students that were trying to do some research papers on it, and it started threatening them. And so, I mean, we want to make sure that that kind of stuff doesn't happen because we do have an area in our society of people that are at risk. And then we have the higher risk, which is more of the critical systems, our transportation, employment. And so those are high risk. There will be a lot more regulations surrounding that. And then we have the unacceptable risk, which they say absolutely not. That's more of the social scoring, kind of manipulation. And it says, interestingly enough, facial recognition, which is kind of funny because we use it for our phones, our computers, we use it everywhere. But it's more of the social scoring type thing related to that. Like they're segmenting you out because of some kind of a facial recognition. So it's important to know that if you're planning on implementing that for some reason, they're going to want to know why, because there are certain areas that you can use it and certain areas you can't.
Yeah, and one things to observe about, especially the EU AI Act, is we are still living in a world where, for many reasons, the regulators are struggling to basically cope with the speed of the market, basically. So if you look, they try to build a regulatory set of rules that are more generic and agnostic possible. So they don't look at the specific technology, but more on the impact of the technology. So that's why, for example, you look at here and you see that chatbots or emotion recognition systems, so technically speaking, behavioral analytics, it falls into a limited risk. But behavioral analytics is tightly related to, for example, facial recognition. And to that extent, if you look at that, basically it seems almost like that, we wouldn't say they're failing, but they're basically missing some parts of it. But actually the idea behind was how those things can be related. So the limited risk of a chatbot or emotion recognition system is because it depends on how it's used. The problem we have is that, like Heidi was saying, if your company basically is an international company specifically, you implement a system that actually, for any given reason, has to serve users that are sitting in Europe, exactly like for the GDPR, for example, you are subjected to that regulation. So you have to provide at least the information or a set of information, or at least you have to have the set of security rules in place that can demonstrate that you can cope with that act. The problem I see there, it's always been there as a problem, is that because this is a government regulation, actually, a regulatory regulation from an entity like Europe in this case specifically, is not fast as we would like. so require a lot of time to make changes and a lot of time to actually to adjust those changes. So typically what will end up is that every time it will be basically fall behind where we are. So there will be probably ways to escape it, but there's always ways that all of a sudden you will be to be back in compliance and you are not anymore. GDPR was a beautiful not, but let's say it was an example of that. Every US company at some point find out that actually to be really check where the data was living because it was subjected to the GDPR and pose it, and it goes back to the implementation cost and etc. If all of a sudden your data need to live in a certain geo just to be sure that you are compliant with things like GDPR, that means basically that you have to have a redundant data center, you have to be careful about what client provider you're using or on-prem data center you're using and why you're using that, and this is basically a cost for you. Because of double down things sometimes, or you have to implement different kind of strategies and rules.
Yeah, and then of course in the US we have the California Consumer Protection Act. We have NIST, which is voluntary, but is a very important framework for people to follow. And then with the US Executive Order, and then HIPAA, of course, for healthcare. But the thing is like you're saying, things change, and we need to make sure that we are on top of all of that, because every single country has their own regulations, and they're constantly changing.
Yep.
And then this is kind of a list of some of the security threats. So we have, and it's definitely not a comprehensive list. We're finding new ones every single day. Yep. So we have prompt injection. That one's important because that's where the users are actually interacting with AI. And that one's hard because we can't always predict the kind of issues that we're going to have. There's some obvious ones, you know, try to inject code, things like that you're expecting. But there's also ones that you don't expect. So for example, they were testing it out and they put write book infinitely.
Yep.
And I did it just for a while, but then I started freaking out and started dumping test data. And just random test data, it gave out some personal information, things like that. So you never really know what to expect. So you need to stay on top of the news, stay on top of what's going on, and help mitigate those risks. Because one thing with security is there's a very, very high probability that you will be breached at one point or another.
Yep.
It's almost completely unavoidable. But you need to be able to kind of put guardrails in place. So if you do happen to have an issue, you need to be able to find it and mitigate it.
Yep.
And then that's one of the reasons why you have observability and guardrails put in place for those kind of things.
And even that, I mean, some of those, they still are there. So for example, if you look at the system prompt leakage, probably it doesn't sound like something happened, etc. But if those of you that remember when Apple launched the Apple Intelligence, 2 weeks later, basically, they were attacked by a system prompt leakage. Basically, people publish the system prompt of Apple Intelligence in the public to try to demonstrate that Apple Intelligence was not that very smart because they built really a huge set of system prompts. Nothing wrong with that, but that leakage has a high impact on the brand of a company. Because you literally go outside and say, okay, here's my company, this is what they do. Oh, those guys are not really smart because they did this. And to be honest, well, they did their job. Whether it's good or not, they did their job. That's it. Unfortunately, being attacked that way. Things like, for example, misinformation, another case, or PII and IP data leaks. When you're writing a prompt to an LLM model, you don't know actually if the model is enabled to go and scrape the web to get your results and going out and asking for that information. Because if it is unable to do that, that means that that prompt you wrote potentially can travel the network outside of a company with your sensitive data in. So if I'm just outside of a company, you don't have to do nothing, if not just sniffing the traffic. And basically I can read your prompt. There are multiple companies that have this problem because in the nature of LLM, sometimes you have agent or you have tools that actually allow the LLM actually to consume data outside just to create a complex and an valuable answer. So those kind of attacks, exactly goes back to the initial statement we made. The more you add information, the more you expand your security surface attack. And the more you expand your surface attack, the more the ramification toward things become evident. You need to be compliant to regulatory. You need to be sure that actually you have an observability and a security tool in place, because you need to know what's going on your infrastructure and when it's going on. For those that actually passed by to the technology showcase, part of a demo we had there was showing that we have a model was trying to basically ping and connect to certain URLs. That is just a normal behavior. We were basically stopping those behaviors, saying, okay, I want to be alerted when the model actually tries to reach out the specific URLs, just to demonstrate actually that is something you don't see, but it happened. And this is something we have to consider. Now, this is just a subset. Currently, there are more than 1,000 potential attacks to an LLM. Keep in mind that these are mostly around LLM, because it's just a subject. Then we have all the attacks to computer vision, all the attacks to the other more traditional machine learning approaches, and all the attacks that are indirect attack to the machine learning, but actually they attack your data. That actually is your valuable information there. Yep.
Yeah. And one thing a lot of people don't really understand with the misinformation is LLMs are created to, these are created to sound human. That's their main function, is to make everything sound right. They don't do the fact checking. And so that's important for humans to do an overview of everything and make sure that everything is fact checked.
Yeah. And like you say, that the way we put in place or take in place an LLM is what we call a guardrail. That is like the word says. A guardrail is really like put two guardrails beside the LLMs and be sure that LLMs at least try to stay within the rules. We are not always precise, because not necessarily we have all the right guardrails there, but actually those are useful for that. From stupid things like, if I have an LLM that acts as a customer support assistant, and I'm on the phone or I'm chatting with the customer support assistant, I don't know he's not a human, so I'm talking to him. And if all of a sudden I or the LLM start to respond using toxic language, the result is that I'm impacting the brand of a company. So I need to have a system that at least stop the LLM to do that, or stop the user actually to do that. Because sometimes it's really about the human. If you start to do stuff, I can go to an LLM, ask an LLM nicely about to write me a malware for me and execute it. And you can say me, oh, well, it will never happen. Well, unfortunately, the technology showcase is closed. Otherwise, I can show you a couple of screenshots of our off-the-shelf models. Actually, are more than happy to write malwares for you. And that's this potential attack that you have. So the guardrails think of the guardrails like a technological approach. It's a framework. It's a way to actually provide. We announced it yesterday, that the partnership we made with Infosys, but there are many other companies. Microsoft is one of those. There are many companies that provide guardrails, and we basically support them within the product, exactly for that reason, to put you in a position where you can protect yourself. So yeah, and that's basically exactly what I was saying. The problem, exactly like Heidi was saying, is generative AI or LLMs, because just to make a proper difference, generative AI is you generate actually a response. In the case of LLM, you don't really generate a response. You simply combine a response based on the information you have. It's a large language model. Now, large language model is not a new things. Have been in the market since a while. They've become a big things in the latest time, but actually been there almost ever. And I have a session after this one where I can show you, but basically the first approach to LLM was a system called ELIZA, and it's like 20 years now old. So they were there. The problem about LLMs, like Heidi was saying, is that they are meant to combine information. So that from that point of view, they are unpredictable. You don't know what it will be the outcome of your questions, because what their job is exactly that, is around looking and consume data, figure out the data, and base it on the context, and based on the cost to give you an answer. And that's why, for example, they tend to have hallucination. They can be fine-tuning. That means that I can, over time, explain the system how to behave, how to provide me. There are certain ways to make it even more precise, like RAG system. So I basically give them documentation and indication to say, okay, when you answer me based on this context, not on something else. But in the majority case, they are not different from any other machine learning model. They're simply like modeled and being trained against a large amount of data, and based on that, that can be refined. But that means that it's not deterministic by design. So you have to, don't expect an LLM to be immediately precise as you like, because it will never happen, even if it is a super complex system. Oh, thank you. So that means that we need to define how the LLM deployment or how the LLM lifecycle look like. So before actually say in a company, oh, let's start, we need to make some considerations. We need to make a plan. The first, this is basically is a good representation of an LLM project, an LLM deployment. Basically, the first part is resilience of first strategy. That basically like, okay, the first step is, typically, the first step is, oh, let's look at the data, because we need the data. Now, the first step is actually, let's look at the potential security threats we will have. The first step is about, if that is the use case we have in mind, what is the potential result of this use case? Where we could be impacted. Because we know where we could be impacted, or we can then visualize where we could be impacted, then we can start to look at the data and say, okay, these are the guardrails we need to put in place. The second step is look at the policies we have. All of us have internal policy in the company. Do you have today an AI policy in place? It's not about LLMs. I'm pretty sure you have AI in your companies. Do you have an AI policy in place? If so, it's been updated related to your latest AI initiatives? Because that's another important step. You plan before you execute. You always do in every single technology we use. AI is no different. Then you train education. Again, like Heidi was saying, this is a system that tries to act and mimic a human. So basically, the result is that it helps us in our job, because it's like having a friendly human that basically helps you in writing an email, summarize the content, or maybe find out information, combine complex information in a simple way and get the results. It's addictive. You start using it, and people start using it. Here's the problem. How they use that? Are they trained to use that system? It's not about, oh, let's put the LLM in production, then maybe we'll train the people, because they will misuse the tool. So you have an AI policy that says that the first step, first, we start to slowly train the people. Probably before you will start from the people that actually operate the agent, and later you will train the people that actually they consume the agent, but nonetheless, that's another part. Then you engage with the leaders. You need to have a structure that says that your company basically is aware of the AI initiative, aware of the security threats, aware of the policy, and basically buy the policy for you. And finally, you start to do the more traditional risk project management program. Because in the end, that's it. I was saying in another session that we were more from a technical standpoint, that AI is not different. It's just yet another workload in our infrastructure. But that means also that AI is just yet another tool we are using in the company. So why shouldn't be in our risk management program? It should be included. And then you finally land on the deployment strategy. Now you are ready to consume that tool. Now you're ready to say, okay, these are the things that we need to implement. As usual, I'm quoting people in the audience without them to know, but there's a gentleman in this room. We were in the same conversation yesterday with one of our customers, and actually, the first question they made to us was, oh, we want to build this LLM. We got everything, and their question was, do you have a data lake? Do you have a data? And they were saying, oh, no, we have to build it. But actually, the real question was like, once you put the data there, how do you protect the data? Did you already thought about how to protect the data? Did you already thought about putting there boundaries that make you sure that that data will consume it in the right way? That's the first step, because otherwise it will be too late. Once you got the system on, it will be too late for you. So that goes you to balance the opportunity and risk. It's really about, you need to move fast, because we are in the nature of business of our businesses is that we need to move fast, but we need to move fast in a secure way.
Exactly, yeah. So this really goes into what he was saying. So you have to have an AI adoption strategy, right? You need to identify what you need it for. What are your use cases? What are the basically, yeah, what are your use cases?
Yeah.
Because it costs a lot to
Yeah.
implement AI, and it takes a lot of tools. And so you want to be able to define what you need it for, so you're not just spending money and throwing stuff out there for no reason at all. And then you need to assess and plan. Like you were saying, if you're going to have a data lake, what are you going to do to protect your data? What are you going to do to what tools you're going to implement? There's so much you have to do. You have to be able to have an AI policy. So you need to really have a plan and a step-by-step process, like he showed you, on what you need to do first. And then, of course, in that plan, you need to have a technology assessment, like we mentioned before. What do you have now? What do you need in the future? Do you need GPUs, DPUs, CPUs? There's so many things on there. Who's going to, where's your data going to go? How are you going to encrypt the data? Do you have the ability to do it now, or do you need to implement new technologies to be able to do it? And then pilot and test. Test. I can't emphasize. You have to test because in a sandbox environment, it's very well controlled, and you can find the errors. Once it hits production, you're in trouble because you don't know how many people has already encountered this problem. You don't know what kind of hackers have been there. I mean, it's very risky. So you need to make sure you do all the tests and then implement it. And implement includes the training the right people to make sure that you have the right tools and the right people to manage the AI that you are actually putting in place. And then monitor and maintain. Like I said, there's going to be a security risk a lot. I mean, you're always going to be at risk. And so you need to be able to find out what's going to happen, whether it's a normal user that accidentally did something wrong or a hacker. If you guys can monitor the activity going on, you can shut down the risk as soon as possible. And always maintain it because technology is constantly changing. You need to make sure everything's up to date. All the security stuffs are in place. And then hopefully everything is good and you are wanting to scale it and make it better.
Yeah, and if you want, and this is an important things, in a slide is not easy to show, but keep in mind that once you land at scale optimize, that's the very moment where you are back to define objectives.
Yep.
Your company change, your business needs are changing. That means you are scaling the actual results, but actually you're starting to redefine your objectives. In the LLM is even more true because it's a new tool, it's a shiny new tool. The moment you implement LLM, business will come to you and say, oh, this is lovely, we would like to expand even more. To give you a real use case that is SUSE, we are implementing SUSE within the SUSE IT. There's been a session the other day. And the moment we started to pitch what we can achieve as initial use cases, we already received tens other use cases from other business units that said, oh, we would like to do this, and keep increasing it. So that is really a closing loop. You keep doing the same because you have to readjust the target every time.
And so I wanted to make sure that we point out threat modeling. It's really hard to see all the details in this, but this will really help you point out where your vulnerabilities are. Are there going to be any data leaks? Where are the users going to do for maybe improper injections? It really helps you have a visual of what is going on in your systems. And this is a very, very, simple example for like an LLM applications for Gen AI.
Yep.
But depending on what your use cases are, it could be much broader. But we need to think of this as like a mindset. It's not just an exercise. It's a mindset that you have to truly understand what you're doing, or you're going to put yourself at risk.
Yeah, absolutely, yeah. And
Want to go back?
no, except, yeah. And that basically goes back exactly to the risk prevention and mitigation. That is more about exactly what we're saying is, the first step is I need to plan what will be the object or the content of the items that will be part of my architecture. Based on that, I can, so for example, I'm picking up randomly a couple of them, like use RAG. How many of you knows what RAG is or RAG means? Okay, more or less, yes. Not necessarily you're going to use RAG. Let's say you want to serve an LLM system to a large company that has tens or hundreds of departments. Now, ideally, you would like to say, maybe I want to tailor the LLM toward each one of the departments, or I want to create a RAG system just for each one department, just because this way each one of them has a precise response when it works. But those departments are interconnected, so you cannot use the RAG that way. So you are already duplicating RAGs there, and it's unmaintainable. And it exposes even more to the security, so you need to find a workaround. If that is an example of planning the system before time, because you start to figure out, I cannot mention the company, but actually there's a company actually went through this recently. They launched a sort of a ChatGPT internally in production. They have something more, they have more than 100,000 employees. And because of that, they find out, trying and failing, they find out basically they were not able to use RAG from that point of view, not because RAG was not working, but because their IT department was so small they were not able to maintain the number of RAG they would have to build. Things like security controls or complete mediation or tokenization and reduction. Again, when you look at the LLM from a security standpoint, people are writing down information, and there's information traveling the network. Sometimes you have to redact the information, sometimes you have to encrypt the information or anonymize the information. But in order to do so, you have to plan system to do that, and so on and so forth. And access control. Who can access to the LLM? Which kind of content can retrieve? Can use the same model of everybody else. Maybe you want to have multiple models, and you want to have access control on that so that people can consume the information, but in a different way. But again, that goes back to the idea that the more you add, the more you have to maintain, the more you are exposed. If you could go next, maybe, or if you want to say.
Okay, one other thing is the really important one for me is the graceful degradation, because you can never have something up, well, almost never have anything up 100% of the time.
Yeah.
So how are you going to handle these issues? What kind of backups and security things you can have in place so that when something does happen, something unexpected, that you handle it well and it's not going to cause a huge issue? And what he mentioned before, we need to build a very strong AI policy. We have to do the ethics. That is something that's not been typically a security issue before with other technologies, but with AI, it definitely is. We definitely don't want past issues coming into what our data is now. We want to move forward with that. Data management, as you mentioned, very critical. Data is like the foundation of AI. And if we don't have good data and a good way to manage the data, then it's not going to go well. And you need to have policies in place for that. So what data is allowed to be put into these, into the AI? Which data is not allowed to be in there? And this a lot will depend on your industry, your industry and what your use cases are for that. Of course, you need to very much document your security measures, your access controls, because you're putting it out for a lot of people. And you're going to have employees come, employees go, and you need to make sure it's well documented so that it's easily accessible to all of them. Of course, compliance and legal, and then training and education. So users, employees, people, they're one of our greatest assets, but they're also one of our greatest security risks. You just never know what's going to happen. So it's very important to train people and not just train them on everything. You don't want to just give them this broad 30-minute session and tons of documentation because they're not going to read through it. So you need to train them on what their use case is with that AI. And then we're going to dive into how we can do it securely.
So let's start from a different approach. This is more a technological approach. This is in the context of an LLM infrastructure, but also in the concept then on SUSE AI. How many of you are knowledgeable, aware, or know the concept of red, blue, and purple teams? So, from a security perspective, yes. Yeah. So basically, just to make it very, very simple, a red team is responsible in IT security to try to attack and break. It tries to break stuff within your company to understand if you have a security threat, what the security threat can be. So their job is really to be proactive in a really simplistic term. So basically they try there and say, okay, let's see actually if we can get in. Because if we can get in, we know how to protect ourselves. A blue team is actually the opposite. Potentially they are the same people, but actually it's just an approach. They say, okay, the blue team is exactly the opposite. It says, I have no idea where the threat is, but when the threats show up, I will try to react. I will try to protect the company and try to fight back. The purple team basically is the concept of be in the middle and work with the red and the blue team and try to secure. So what we are trying to do with SUSE security, in the concept of SUSE specifically, is basically be the purple team for you. So if you look at the things, we can say, okay, we can more or less identify the kind of attacks. This again is really a subset, just more for the definition of attack and where those attacks potentially can happen. Not necessarily this is like, okay, service disruption attacks is just at the hardware level. It's more about a service disruption attack is something that you perceive from that level simply because it basically puts you in a position where you can have anything else. Does it happen often? Well, yesterday Amsterdam airport has been shut down because they have an IT problem. Is it an attack? I have no idea, but it was shutting down. It's a big airport. It's one of the biggest hubs, probably the second hubs in Europe. And it hit the entire world because the moment Amsterdam airport stopped working, we have delay everywhere. So that's pretty important. This is a security at LLM level? No, this is more traditional security. So you need to have a tool that is allow you to basically do stuff like deep packet inspection, network topology inspection, and so on and so forth. And you are still here. But the moment you move up, you start to hit the application layer. Let's call it like that. So vector database, the RAG system basically is just nothing more than get the content you provide, place it in a vector so that actually the LLM system can read the vector and figure out the answer. But if the data that is in the database, in the vector database, is being poisoned, my LLM will give me some, let's say, creative answers. Maybe they're even more interesting, but you never know. So the problem becomes that this could be red and blue for sure as a team. But the more I grow, we start to see that we divert from that route. In the majority of cases, like in security data inspection, in security for LLMs especially, you tend to think that this is just a blue team. It's just about, oh, well, here's a model. Who cares? The model is secure by design, so who cares? But this is where we actually introduce a red team approach. Guardrails are a blue team approach. They simply react based on the outcome or the income of the information. You write something toxic, I stop you. The LLM has an hallucination, I stop the LLM. But at the model level, what we are basically building and offering is a way to attack or try to attack the model. And if you go on the slide, I think I have. Oh, no, you can come back down. I remove it. So that basically is the way you said, okay, you put a model in production. What I will do from a SUSE security will try to attack and jailbreak the model, try to break the model, get a result out, get a report out of the attack that I did, and tell you this model is subjected to this kind of attacks on a regular basis. That means that anytime you put in production, well, not put in production, you want to try a new model, every time you want to try something new, I will give you a nice report that says, this model is subjected to this kind of attacks. I'm not going to solve that problem. I'm not going to fix that problem because this is not my job as a SUSE security, but I will make you aware of where the problem is. And you need to be aware, just because for compliance's perspective, that's enough to be compliant in majority of cases. We all have to remind ourselves that regulation doesn't say you have to fix these. Regulation in the majority of cases says you need to demonstrate that you are aware of your security threats because maybe you are not in the position to fix them yet. But the only way to do it is basically through a tool that actually allows you to generate this kind of report. So if you look at the SUSE AI perspective, and I'm not doing a marketing pitch right now. Marketing pitch will be the next session, basically. So if you move there, then I will say something really cool about that. But actually, That's why when you look at the platform, you don't see an end-to-end platform. You see a platform that says, here's the building blocks you need, here's the security blocks you need, here's the observability you need to know what's going on. There's a partner or a customer or your solution there, but it's not that we don't care. We don't come to you and say, I want to be agnostic, I want to help you, but I'm not going to be opinionated. I let you do your job, you know your use case, you know how you want to solve your use case. We simply give you the tools to protect yourself or to implement the use case. And those tools, this is what we care as an infrastructure company, because those tools basically put you in a position to be compliant with the regulation, with your policy and everything else. Questions? Feedback? You want to dance, sing? For those that karaoke yesterday evening, I don't know if you were there, it was pretty challenging. If you saw me yesterday, it was not me. I have a twin, crazy at the night, trust me. It's a complex thing. What we keep saying is, we are in a really bad situation right now because our companies ask us to move fast and implement this stuff because they want the shiny tools. But on the other hand, we really need to evaluate how these tools fit into the current infrastructure because it can disrupt the infrastructure easily. Luckily for us, there are many approaches, as you see, like guardrails is just one of them. Many approaches that can protect you because in the end, it seems a shiny tool. It's there since 20 years. We were making LLMs 20 years ago. It's just evolved. But we need to remind ourselves that this is just yet another tool in the infrastructure and need to be fit the current security landscape of the infrastructure. Otherwise, we will basically just create a mess.
Okay.
Thank you for listening to us.
Thank you.
Safe
Appreciate
travel
it.
back home.
Thanks.
Hope you enjoyed SUSE.